and Assalamualaikum. Today we are going to present our video presentation, which is High Performance Liquid Chromatography HPLC. First, let me introduce our group member, which is Putri Nur Farisha, Nur Shahira Najib, Dania Uzma, Nur Fatin Nuha, Batrisha and Nur Hazira. There is 5 topics that we are going to present in this video, which is introductions, methodology, result and analysis, discussion and also conclusion.
Hi and Assalamualaikum. Let's first talk about high performance liquid chromatography, also known as HPLC, which is a sophisticated and powerful analytical technique used to separate, identify and quantify components in a mixture. HPLC leverages a liquid mobile phase and a solid stationary phase under high pressure for a precise chemical separation. It also utilizes a liquid mobile phase to move analytes through a packed column. The separation occurs as components of the mixture interact differently with the mobile and stationary phases, and this differential interaction is based on physical and chemical properties such as polarity, charge, and size. The liquid mobile phase ensures the analytes are dissolved for a smooth movement through the column under a high pressure. HPLC also described as a versatile analytical method because of its wide range of applications. It can separate a non-volatile compounds that cannot be analyzed by gas chromatography and thermally unstable compounds which degrade under a heat. HPLC operates at high pressure, enabling efficient and rapid movement of analytes through the tightly packed column. The high pressure increases the interaction between analytes and the stationary phase and improves resolution, sensitivity, and speed of analysis. There are 3 objectives of high-performance liquid chromatography HPLC, which the first one is to determine the retention time of a standard solution caffeine, and the second one is to identify the caffeine peak in a soft drink sample. Lastly, to determine the amount of caffeine in soft drink sample using the response vector method.
I'm going to explain about the methodology of high-performance liquid chromatography. A reservoir holds the solvent called the mobile phase. A high-pressure pump is used to generate and meter a specified flow rate of mobile phase, typically millimeters per minute. An injector is able to introduce the sample into the continuously flowing mobile phase stream that carries the sample into the HPLC column by using a syringe. The column contains the chromatographic packing material needed to effect the separation. This packing material is called the stationary phase because it is held in place by the column hardware. A detector is needed to observe the separated compounds bands as they elute from the HPLC column. Most of compounds have no color, so we cannot see them with our eyes. The mobile phase exits the detector and can be sent to waste or collected as desired. When the mobile phase contains a separated compound band, HPLC provides the ability to collect this fraction of the elute containing that purified compound for further study. The instrumental parameters consist of the flow rate of mobile phase, column, detector, mobile phase, and the ratio of mobile phase.
Okay, this is the methodology for experimental part for solution A. Step first, we must to accurately weigh 10 mg of caffeine into a 10 ml volumetric flask. Step 2, dissolve in distilled water. And step 3, make up to volume with distilled water. Okay, next we move to solution B. Step first, pipette 1 ml of solution A into a 10 ml volumetric flask. And then step 2, make up to volume with distilled water. Okay, this is for sample preparation. Step 1, pour about 10 ml of soft drink sample, cook and leave it into a small beaker. Step 2, use a magnetic stirrer to remove any carbonation. And step 3, filter 2 to 5 ml a liquid through a 0.45 micrometer pore diameter membrane filter particulate method. For step 4, inject 10 microliter of solution B into the HPLC to establish the retention time of caffeine. Step 5, measure peak area of caffeine. And step 6, inject 10 microliter of the prepared soft drink sample into the HPLC instrument and measure the peak area corresponding to caffeine by referring to its retention time.
So now we're going to discuss the results for the experiment. So first here we have the sample standard caffeine. The retention time is 2.482 and the peak area is 6249,48779. Next, the sample for the Coke, the retention time here 2.481 and the peak area is 7001.12305. And the last sample is Levita. The retention time is 2.479 and the peak area is are 1.11511 and 11151.10000. So here in the analysis is the summary of the graph that I've taught earlier. The name and the model that we use for the experiment is high performance liquid chromatography, HPLC. So here is the compound, the retention time, and also the peak area of the caffeine. In this slide, we're going to see the calculation of the response factor caffeine, the concentration caffeine in Coke sample and also in Levita sample in ppm. So for the response factor here, we got 62494.878 milligram per milliliter. For the concentration from the response factor, we're going to use it to calculate the concentration caffeine in Coke and Levita sample. So in concentration caffeine in Coke sample here, we have 112.027 ppm. And in concentration caffeine in Levita sample, we got 178.432 ppm.
Moving to our discussions, the main objective of the experiment was successfully achieved in these experiments, which allowed for the determination of the caffeine standard solution retention times. Also, successful to identify of the caffeine peak in each of the various samples under investigations, which is soft drink like Coke and Levita drinks. Also can determine the each sample caffeine content by using the reaction factor methods. Then, the high-performance liquid chromatography instruments was used in this experiment because it has the ability to separate the compound that is present in the samples. For your information, HPLC is very versatile because of its ability to easily separate a wide variety of the chemical mixture, which include the non-volatile and thermally unstable compounds. And by using the instruments, it's easy to detect and separate a combination of molecules that include in the standard caffeine, Coke, and Levita. According to the result, there are a few key factors that must be considered in order to properly interpret the provided chromatograms. So, in this experiment was focused on the retention times, peak area, peak heat, and the comparison of the sample with the standard. So, retention times are used to identify the specific components in the sample by comparing it to the non-standards. Next, the peak area shows the relative concentration of the substance in the samples. Where the larger peak area, the higher the caffeine contents in these experiments. The caffeine peak in the Coke and the sample can be identified based on the similarity of the retention times of the standard caffeine. Moreover, this experiment obtained a standard caffeine retention times, which is used as an indicator to determine whether the caffeine is present in the sample of Coke or Levita drinks. And the analysis findings demonstrate that both samples have contained the caffeine, with the retention time for Coke and Levita drinks being close to the standards at 2.481 and 2.479 minutes respectively. And according to the calculation and scientific data, the standard caffeine response factor was successfully obtained. The caffeine concentrations of the Coke sample was determined to be 112.027 ppm by using the provided peak area. However, it was discovered that Levita sample had a caffeine concentration of 174.432 ppm with the provided peak area too. And based on the result of each sample caffeine concentrations, it can be concluded that Levita drinks have more caffeine than Coke. To support these statements, it was because of the strong illegal compositions of organic solvents in a high ratio than water. The Coke drinks have a more carbonate than Levita drinks. And since Levita drinks have more bigger caffeine peak area and have a shorter retention time than Coke, the Coke drink will dissolve more slowly. and the cold drinks will dilute it later because it has a greater retention times and make it have a shorter caffeine peak area.
To conclude, in this experiment, we have determined the retention time of standard solution of caffeine, which is 2.482 minutes. Next, for the caffeine peak area, in soft drink sample have been identified, which is in the Coke sample was 7001.12305, while Levita sample was 11151.1. Lastly, the amount of caffeine in the Coke and Levita using the response factor method was obtained, where the concentration of caffeine in the Coke was 112.027 ppm, while the concentration of caffeine in Levita sample was 178.432 ppm.